Okay, Cami, so what, shall we start? Can you just introduce shortly?
Yes, okay. Так, давайте начнем. Добрый день, приветствую всех и благодарю за участие в сегодняшнем нашем вебинаре. Я так думаю, вы меня не видите. Я представлюсь. Меня зовут Камила. Я представляю компанию Power из Польши. Со мной сегодня также моя коллега. Ее зовут Анна. Она ведущая сегодняшний вебинар. Как я сказала, мы представляем компанию Power из Польши. Мы здесь сегодня по приглашению наших партнеров из компании SLO. Мы с ними сотрудничаем уже 5 лет успешно. Дорогие коллеги, благодарим за приглашение и возможность сделать сегодняшний вебинар. Итак, я сделаю для вас коротенькое введение в тему вебинара на русском. Основная часть, техническая, будет сделана Анной на английском. Она так предпочитает. Вот вы видите содержание и тема сегодняшнего вебинара. Это главные положения новой директивы Евросоюза по экодизайну и главные изменения в этой директиве. Потом мы обсудим также тему правильного выбора сухого трансформатора. Потом у нас будет вопрос о будущем сухих трансформаторах. А потом у нас будет также время на ваши вопросы. Дорогие слушатели, если у вас возникают какие-либо вопросы, пишите их, пожалуйста, в чате на английском, либо на русском, либо на латышском, как вам удобно. Мы и наши коллеги из компании SLO будут отвечать вам на ваши вопросы в рабочем порядке. Как написано, время у нас... Сколько у нас времени? 75 минут на весь вебинар. Надеюсь, что это будет для вас интересно. Еще раз скажу, если есть вопросы, пишите, пожалуйста, в чате. Сейчас я передаю голос моей коллеге Анне. Анна у нас специалист, ведущая вебинар, а также директор по продажам компании Power. Anna, please proceed.
So, I just apologize because my Russian is terrible, so it will be really be more concentrating on what I'm saying and not about the content of what I'm saying. So that's why I prefer to introduce all these arguments in English. As you see, Kamila speaks perfect Russian, so in case of questions, she's at your full disposal. We start with very short presentation of our company, just 3 minutes, and we switch to English. So Kamila, could you just shortly introduce Power, and then I will start with our technical presentation.
Хорошо, давайте продолжаем. Сейчас я буду на английском буду говорить. Here's a very short presentation of our company, Power, from Poland. This is what we do. We are a manufacturer of cast resin transformers. This is how our factory looks like. We are based in Siemianowice Śląskie. It's in the south of Poland. We are a small company, 25 employees with 15 years of experience and a yearly turnover of around 8 million euros. And we have our customers base worldwide in all continents. Oh, here's where we are based, in the south of Poland. And you can see that we manufacture according to all standards. But our priority standard is ekodizaina, tier 1 and tier 2. But also GOST, IEC, ANSI. Apart from production, we also do routine tests. Further tests on request. This is the map of our customers worldwide. As you can see, all continents, not only Europe.
Actually, Australia is missing here.
Yeah, Australia is missing, but there are both Americas, Europe, Africa. Okay, our standards. Our power range starts from 10 kVA up to 5 MVA. The limit is, for now, the weight of 10 tons. Voltages starting from 1.1 up to 36 kV, sometimes even higher for Russian market. Our standards, as I said, standard reduce or eco losses. Now we are ready for tier 2 for new directive. All possible applications, mostly distribution, but not only, converters, step up, step down, excitation transformers, transformers for solar plants, windmills, earthing transformers, for railways, for the ships. We use different materials, but for windings, both aluminium and copper. Here are some photos of our factory, assembling department, test room, and our equipment for testing. Here are examples of special transformers. Next photo, please. Okay, more special transformers. Example of multi-secondary voltages. Converters, solutions for seismic areas, protective enclosures, connections inside the enclosure. This is for the UK market. And a big power transformer, power 5,000 kVA. Customized solutions, different colors of the IP enclosures. Everything on request. Customized finishings of the clamps. And our accessories, such as forced ventilation, anti-vibration pads, and devices for temperature control. And that's it. Thank you.
So this was very, very short presentation because we do not want to lose too much time.
I mute.
Which are not that interesting for you. Now we start with the main presentation. Here we concentrate on the eco-design regulation, which entered into the force in July 2015. The rule was defined in May 2014. We had, as manufacturer, 1 year to adapt to the new rule. It was not very easy, I can tell you, because the losses have been reduced by very, very important way. This you can see on this slide. We had to reduce the no-load losses by 30% and the load losses by 20%. At that time, in 2015, the material, how can we get these losses? Of course, we have to reproject the transformer, change the basic material for the core. At that time, in 2015, there was a really very bad situation for all manufacturers of transformers, because the steel which was adapted for this kind of losses was not available at the market. So according to our experience at what we have calculated in that year, almost all manufacturers reduced their manufacturing by 30%. So it's incredible, only because there was no material available on the market to guarantee the requested quantity of transformers. That material is called lasered steel, and at that time was produced in very reduced number in Europe. We had to import it from abroad. So that's why there was a big problem to achieve this goal of 30% low losses and 20% on the load losses. The new regulation was divided into steps in tier 1 and tier 2. Tier 1 it's already working. We are supplying all transformers inside the European Union according to Tier 1 for all distribution transformers. And since 2 years, we are already supplying also Tier 2 transformers, requested mostly in Germany, but also in Scandinavian markets who are very sensible because of ecologic problems. So they save the money, but they prefer also to buy more ecologic transformer. So next year, starting from the 1st July 2021, we have step 2. So eco-design tier 2 is entering into the force. It means that we will still have to reduce the losses, the no-load losses, by 10%. At this time, this is absolutely not a problem. Many manufacturers started already 1 or 2 years ago, as we did, with production of this kind of transformers. Reducing the losses by 10% is very easy. It's not that difference we had before. But what is interesting, when the first regulation was published, everybody was convinced that tier 2 will never enter into the force because it's impossible to reach the numbers they pretend. And it is impossible to afford also the costs of the transformers. Nowadays, we know it's possible. And just to confirm this second step of the regulation, on 18th of November 2019, there was a new regulation which is modifying the eco-design tier 2 stage. This is very interesting point. Just to remember you shortly, with the first regulation tier 1, the losses were reduced by 30% by no load losses, 20% by load losses. There is no tolerance on the losses, so it must be 0. The only point which is confirmed is 5% tolerance on the final checks, but it means if the transformer is checked by a public entity, it's not valid for the private market. Okay, so if somebody is telling you that there is a tolerance on eco losses of 5%, this is not true. This is just to permit the small tolerance on the measurement on the final utilization point. So it's not for private market, let's see. Other important points on the plates on transformer, starting from the first stage, there's mandatory to put the losses level and the measured values. So this is very important point. We need also to put the type of material and the weight of this material. So on each plate, you will find how many kilograms of copper or aluminum has been used to produce this transformer. And the CE marking is also mandatory. So just another table where you can see very well how the losses will change. Till now, we had not to guarantee lower losses for transformers up to 630 kVA. This will be not more that will be not valid anymore. We have to guarantee also 10% lower losses by transformers starting from 1 kVA. There is no tolerance, as I said, but the transformers are a little bit bigger. Transformers produced according to tier 2 will be a little bit bigger and heavier. This is the first point you will notice. They guarantee any case the reduction of operation costs, of course. Just from the beginning, there were some transformers which were excluded from this kind of regulation. So the regulation applies to distribution transformers generally, and applies not to special executions. Special executions are instrument transformers, low voltage transformers generally, and traction transformers, starting transformers, also earthing transformers, and many other transformers, which are listed here. Don't worry, you don't have to take photographs or stuff like this. You will receive all this material later after the webinar if you require it to our partner in Latvia. So let's see what's happened in November 2019. Modification. I just make some very short description of what has changed. So first point, there was not clear if photovoltaic and windmills are distribution or are not distribution. So this time it is confirmed. Also, transformer for photovoltaic application and windmills must be produced according to ekodizaina tier 1 and tier 2 starting from the next year. There is also confirmation that the traction transformers are excluded from the regulation. That these 2 points were not very clear. Another modification, which is not listed here because it's not maybe interesting for us, there are some changes specific for Czech Republic. They have different insulation classes, and it was just shortly adapted to their market. Modification referred to the definition. This is also a point which was open. It must be clear that medium voltage transformer is everything up to 3150 kVA, insulation class 36. Large transformers started from that power, so from 150 kVA, and goes over the insulation class 36. This is the Czech Republic application I said before. I thought it was not written here. So you can see they have a little bit different voltages. Another point, also the pool-mounted transformers have been extended up to 400 kVA. Till the last regulation, it was up to 250 kVA. So now we have also 400 kVA, and they are also included in ekodizaina. This is also maybe interesting point for you about the repaired transformers. In case of repair, replacement of one winding or of the core, anyway, the regenerated transformer must still comply with the current ekodizaina requirements. This is a very important point that was not mentioned in the previous regulation. It's a new point here. So the rule is valid for all distribution transformers. In case of different application, it is treated like an exemption, of course. So if we are repairing a big power transformer, this is not applying to that kind of transformers. There was a short update also referred to the technical tables. I have just listed few of them. It's referred to the class 36 kV. This is quite high class for medium. This is the higher step for the medium voltage transformers. So the losses has been defined and described also in this new regulation very clearly. It's referring to a combination of winding voltages or dual voltage in one or more windings. So as you can see, the losses are here defined by plus 15 and PO by plus 15 and PK plus 10, or basing on which voltage we have to do, are changing a little bit. I will not list them all. We have a copy of this new regulation from November 2019, also in Latvian language. Russian is not available, sorry. We will send it to you, to our partner. So if you want to have a look directly, you can see it also by yourself. So this regulation refers to dual voltage on one winding. Then we have also dual voltage on both windings. The losses are going from 10 up to 20%, basing on what kind of transformers we have to do. What is maybe the most important point of this new modification is the new peak efficiency index formula. What's happened? the first formula was not considering the fact that there is also a part of power used by the fans during the works, during the operation of the transformer. So if you look at this new formula, you will find this new point, which is PCO, and is referred to the electrical power required by the cooling system for no-load operation. So the new formula has been extended in that case. There are also some changes referred to the documentation. This is also very important. The manufacturer has a central rule in this place. If we are supplying transformer which is not produced according to the eco-design, tier 1 or tier 2 later, we have to produce all documentation which is confirming why we are not supplying eco-design transformer. And the whole responsibility, so the legal responsibility for supplying a new non-eco transformer to the European market is on manufacturer side. So we answer in case there is any legal problem. I prepared for you also a short comparison between tier 1 and tier 2 savings. It looks not so wonderful if you if you have a look here. So everybody is convinced that the savings by tier 2 are extremely high. It's not that true. We made already the big step forward with the first tier 1 introduction. Tier 2 is just reducing the losses by 10%, the no-load losses. So the difference in costs cannot be so enormous. As you see, if we compare, this is also a formula we can supply you if you require. Just get in touch with our partner. We have an Excel file if you want to calculate on yourself the costs. We can supply it to you. So as you see, I'm considering that a cast resin transformer must work for at least 25 years. This is minimum medium operation time of such transformer. In that case, we save just buying tier 2, we save €370 per year. This is calculating basing on the Polish energy costs. Of course, it's changing based on the costs of the energy. Some countries are more economic, some countries have much higher costs. Just for your information, if I take the costs of the UK energy producer, we are talking about not 0.13 euro per kilowatt hour, but we are talking about 0.9, yes, right, that's correct, 0.9 pounds kilowatt hour. So the costs are extremely high in case of UK, for example. That's why UK is really the first leading country switching to amorphous transformers. But this is something we will see together later. Okay, so if you see the graphics, the green line is referred to the standard transformers, the red line to the tier 1 and blue line to tier 2. So between tier 1 and tier 2, there is really small difference. But as I said, starting from 1st July 2021, we are obliged to supply exclusively tier 2 transformers to the European market. Okay, that was the first part, referring to our to the rules, to the new rules of eco-design tier 1. Now we prepared a short list for you to help you also to choose the right transformer. By the way, I'm never insisting with the clients to convince them to buy a cast resin transformer. We produce just cast resin transformers, but for some applications, it's clear oil transformers can be much better and useful than cast resin transformers. In distribution markets, cast resin transformers are really winning a lot of market this is because of their safety reason. They can be installed inside the buildings. There is no problem of the fire, etc. But for some applications, when we see that the costs of cast resin transformer are exceeding really too much oil, we also invite our clients to consider to buy an oil transformer. So this list is basing, of course, on cast resin transformer. I prepared, together with Camila, this list for you because we saw different problems appearing during our 15 years work. How to choose the right transformer, short guide. Choose the right transformer based on long-term savings. So check always all technical data you need, and be sure that if in the future you need, for example, to switch to another voltage, why don't you buy directly to voltage transformers? We also produce them. So this is absolutely no problem. You can ask for 2010 kilovolt to 0.4, and then you switch without buying a new transformer. So consider always the savings. It means also check what is the best solution in this moment and what is your budget at your disposal. Of course, everything must be done according to the rules. Indicate also the correct application of the transformer. Many clients consider converter transformers, so rectifier transformers, as distribution. It's totally different use. It's true that you can use also cast resin transformer in distribution execution for converter, as converter, but you have to decrease the power in that case. So if you have 1000 kVA, you can use it as 800 kVA for converter application. But consider that probably the warranty of the transformer will be not granted if the manufacturer discovers that you are using this transformer as converter. And second point, you have, by the buying distribution transformer and using it also for a 6-pulse converter, consider the point that at least you have to add the electrostatic screen between the primary and the secondary voltage. This is already protecting your transformer a little bit from the harmonic contents coming from the net. The next point is really very important. You have to give all possible information to your supplier about the installation side. So is it hazardous area? So it's an area where you have a lot of dust, a lot of problems with humidity, or your installation is very close to the seaside, or there is a high level of vibration, or you are installing in seismic area. Somebody may laugh now, but I'm not sure if you know, but all cast resin transformers produced according to ekodizaina and generally according to ESC rules are grounded up to 103 G. So it means 3 in Richter scale. They are grounded from standard execution. Nobody may ask you to pay something more for it. It must be done because it's a rule. So all transformers are grounded up to this level. Important point, silicon-free execution. For example, this week we are supplying some transformers to Germany, to Daimler, and it's a quite big, huge order. We have different, more than 10 units, 2000 kVA in silicon-free execution. Silicon is used a lot by cast resin transformers, so you have to be sure in this kind of, if you have this information, to give it to your supplier, because some parts, some components must be exchanged, replaced with different material. Also limited space. If you have limited space to install your transformer, calculate well also the ventilation of the installation site. And if you need the fans, of course, it is always the rule to ask for the predisposition for fans on your transformer, even if you are not buying the fans. We saw that many, especially Italian manufacturers, what they do, if you do not declare just from the beginning that in the future you want to install the fans, they will reduce the heights of the transformer, and also the lower yoke will be reduced, the installation level will be reduced. And in that case, you have no possibility to install later the fans, and maybe you will need them. So when you are placing your order, really, this is our first advice, please always write, you need the predisposition for future fan installation. Okay, it's also very important to inform your supplier if you know that there are some distortion problem in the network. This is just to be sure to get the right transformers and also the right protection inside the transformer. You're investing a lot of money by buying transformer, 10, 12, 15,000 euro. Additional protection means maybe 0 cost or 10 euro, but it's protecting your transformer from any problem coming from the net. So just be sure, if you have this information, just give it to your supplier. And very important point I'm always underlining many times are the partial discharges. The real quality of cast resin transformers are the partial discharges. According to the rule, the partial discharges must be lower than 10 picocoulomb. For some applications, especially if you are supplying to, if you are working with the German market, they ask also for 5 picocoulomb. I'm talking about partial discharges on transformer, not on the windings. So this is also the point you should check. Sometimes somebody's writing 10 picocoulomb on the winding. No, it must be on transformer. Why do I underline this point? This is really very important point. As manufacturer, I'm not obliged to put the value, the real values of your transformer, of this parameter, but as power, we do it. We put always this value because the client must know what are exactly the partial discharges of the transformer. And I'm very proud of it because our medium value goes from even from 3 picocoulomb maximum up to 6. In some rare cases, we have also 7 picocoulomb. So we are much lower than the rules are prescribing. It means the quality of our windings is good, it's nice, and it means there are no many weak points on the windings in case of short circuit problem or any other problem in the net. Another very important point is the certification E2, C2, F1. Many clients do not know that who's declaring production according to E2, C2, F1 rules must have also a certification for it. This is mandatory and the rules are very clear. I know at least 80% of Polish manufacturers declare these rules have no certification for them. So just for the future, ask always for the certification, but because it means they have been really tested and they can pass this test. I can tell you E2, for example, is very difficult to pass with ekodizaina transformers because we have special insulation material, which is not easy to work. Also, C2 is not easy. F1 is a disaster with ekodizaina transformers. So who has the certification means has worked really hard to get these good results, and his products are certified. Just for your information, in Europe, there are just 2 labs who are authorized to do this test. The first one is CHEMA in the Netherlands, and the second one is CESI in Italy. So the certification can be done just by these 2 companies. I saw many other certifications which are absolutely not according to the ESC rules from other labs. believe me, they are not conform to the eco design. So who's declaring these classes is declaring false. Other point, very important point actually, is also the price. Don't buy too cheap, don't buy too expensive transformer. If the difference between medium price level is 20%, there is some trick. So I really ask you to evaluate your purchase before you get the super hot Black Friday offer, because it could mean that in 5 years you have to buy a new transformer. So just get sure that the offer you get is correct, it's including everything, and also the losses are guaranteed according to the rules. So just a short comparison between an old, not eco-design transformer and a new tier 1, in this case, transformer. As you can see, in 25 years, you save something like 30,000 euro. So it's a quite nice medium class car, we can say. So this step has been done in 2015, and I think we could not wait anymore. These savings are not that extreme by tier 2, of course, but the first step has been done. So also replacing old transformers with new transformers, eco-design means really saving a lot of money in the time. Forced ventilation of installation room, we have just prepared short description, very short description of how to calculate the ventilation openings. This is also information we will give to you later, so you can keep it for you. I'm just accelerating because I saw we do not have so much time. So forced ventilation, also something we can supply. I have just one indication for you. Be careful when you are installing also air conditioning inside the room where you have the transformer. The fans, well, the ventilation, the conditioner cannot blow directly on the transformer. Otherwise, what's happened? You are creating a cold point on the transformer, and there could be some problem, compensation problem on this transformer. So you could damage it even. So never blow the fresh directly on the transformer. Partial discharges, what we have, what I have told you before, very important point, just ensure you get the correct level of partial discharges, certification E2, C2, F1. If somebody is saying that has the certification, just ask for the number. With this number, CHESI 1710034, you can find it immediately online. Another very important point we noticed, especially in Baltic area, but also in some countries like, for example, Ukraine, that somebody is playing with the eco-design rules. So on the left side, you can see a typical specification for tier 1 transformer with the losses for, this is 100 kVA. I just took a small transformer as an example. Just ensure that in the part tolerance on losses, you have 0%. It must be written. And also the level of losses, it must be specified. Eco-design, tier 1 or tier 2. On the left side, you can see something which is really not permitted. Somebody is writing eco, not eco-design. Eco. The losses are eco-design losses, but the tolerances of losses are IEC 60076. It means plus 15%. So be careful if somebody is playing with this. It shouldn't be offered in Europe, but we found more offers with this question and this problem. Okay. And now I switch to the last part. This is, let's see, the part talking about the future of the transformers market. I'm always concentrating on cast resin because this is our business and we are experts in this field. Oil transformers, we do not produce them, we do not sell them. I did some comparison for you between tier 1, tier 2 and amorphous transformers, which seems to be the future of the market. So just look at these two pictures. We have on the left side, you see typical amorphous execution. As you see, it's totally different design. The windings are not round, they are more squared. And there is a special structure fixing the amorphous transformer around. Why? The core, which is produced here, is made in totally different way than the traditional, let's see, grain-oriented core. The material is also totally different. If you take a chocolate, the chocolate normally has this silver material. Before you start to eat, you have to remove it. So that part, this kind of metal material, it's very similar to amorphous steel. It's very thin and it's really very difficult also to manage. What's the difference? Oh yes, just for your information, CRT are cast resin transformers produced according to grain-oriented, from grain-oriented steel. AMT are amorphous metal transformers. Amorphous metal transformers are extremely efficient transformers, of course, and we call them matte glass because they are produced with this new alloy from it's iron combined with boron, silicon, and phosphorus, and in form of very, very thin foil, rapidly cooled from melt. In fact, if you look at the structure, the crystalline metal, this is the traditional steel we are using by tier 1 and tier 2. And amorphous material is, its structure is totally different. And this is, of course, changing the physical properties and also the electrical and magnetic properties of the material. There are many advantages of amorphous material. I just listed few of them. The most important point is, of course, extremely low losses, PO low losses, so 70–80% lower than by the traditional grain-oriented steel. Of course, high magnetic susceptibility, low coherency, high electrical resistance, saturated induction, but there are also some negative points. Lower efficiency at full load. That's why this kind of material and the most amorphous transformers sold here in Europe are exclusively distribution transformers. All distribution transformers are almost in all countries run up to 70–80%, not higher. For that reason, this kind of transformers, amorphous transformers, I mostly used, in 99% are used for distribution market. The biggest problem probably is also the size, which is not compact, and the weight. You will see in 10 seconds, I will show you the difference between the weight of traditional transformer and that one. Also, the amorphous transformers are extremely expensive, and this is because of the labor cost. They are very difficult to work because this kind of steel is really hard to work. At the beginning, it was just possible to assemble the core by the hand, so the people had to do it. Since 3 years, there are super new inventive Georg machines which are able to assemble even that core in automatic way, but they are still not machines to assemble the transformer. So the cost of assembling of this kind of amorphous transformers are still very high. There is also a problem by the test of short circuit, especially because this material is subject to short circuit is changing the form and also the characteristics. So they discovered that there could be a big problem with partial discharges of this kind of transformers. For that reason, the most power of this kind of transformers is limited from 50 to 1000 kVA, which is typical for distribution market. Here you see the first comparison. This is for insulation glass up to 12 kilovolt. You can see the costs, which are costs of tier 1, tier 2, and amorphous transformer. I just underlined the losses. In case of PK losses, there is no difference, of course. The only difference is on offload losses, so PO, extremely high. But you can also see the size, which is extremely big, and the weight. Not everywhere you have the possibility to install 1000 kVA transformer, which is weighing 5,300 kilograms. By the way, the costs here are just indicative. I just took the market costs. These are not our prices, just for your information. So I make also some comparison. How much can you save using tier 2 and amorphous transformer? So as you can see, the yearly difference is around 1,150 euro. In 25 years, you are saving around 22,000 euro. So it's quite important. Here you can see the graphics. The red line is for tier 2, the blue line is for amorphous. I'm just comparing 2000 kVA transformers. Here we have the comparison for 1000 kVA, 24, insulation class 24. And here the savings are lower. It's around 15,000 euro if we consider 25 years of operation time, around 754 euro. Now you have the answer why in Europe we do not use these transformers. They are quite expensive, and they still have some technical problems which have to be cleared, but they are really super efficient. And I'm quite sure they will be the future of the market. In the last 5 years, our statistics show that the German, Scandinavian, but also French market and also British market have increased the purchase of this kind of transformers for public lines, so for public utilities, around 20%. So we are moving in that direction. But of course, because of few technical questions and the extreme costs of these transformers, at the moment, they are not very used in Europe, but they are extremely used in India, in China, and in the United States. These are the 3 biggest markets for the utilization of amorphous transformers. Okay, this is all what I have prepared for you today. I hope it was interesting